Good morning, Met 101 students. This is the fall 2022 lab number 1 quick tutorial. This will get you started on the first lab. Now there's nothing that I'm going to show you in this video that isn't already in all of the weather forecast tutorials, but I thought it'd be nice, instead of using old data for LaGuardia, that we do a little walkthrough using today's data, which happens to be Philadelphia. And this video is the same for both my fully online class and also the one that I'm going to meet this morning, where I actually hand out the Foose and Moss, and we meet in person on Mondays. Okay, so we come to the home page, and you want to scroll down, and you want to go to Forecast City Data. Okay, and Forecast City Data today, the forecast is Philadelphia, as I told you. The goal today is to complete this forecast note sheet. Okay, so I'm going to click on the forecast note sheet, and I'm going to save it. Okay, show in folder. I'm going to save this file, so I'm going to move it or copy it, and I'm going to put it in a special folder that I have on my thumb drive, if I can get here, on my thumb drive, Fall 2022 Labs Philadelphia. Okay, so I'm going to paste my document there, and then I'm going to rename it. I'm going to call it the PHF, Philadelphia Note Sheet. I can get rid of this other stuff. So anyway, call it something so you know what it is. So basically, each week you're going, other than this week you're only submitting one file, the note sheet. Every lab after that, you're going to be submitting the note sheet plus the forecast explanation sheet. So you want to make sure those two documents have a file name on them, so you know which city it is and which actual document it is. I've had students in the past uploading the wrong documents, and you don't get credit, you get a 0. So make sure that you have a specific file name so you don't make that mistake. Okay, so let's open up our note sheet. A little slow here this morning. Okay. Okay, so student name, you're going to put it here. I'm just going to write Key. The city is Philadelphia, city of brotherly love. And today is Monday 9-12. Okay, so for the today box, you want to put Monday 9-12. Tuesday 9-13 is going to be what we call day 1. Here we're going to do Wednesday 9-14, and then Thursday 9-15. So pretty much every time you do this, it's going to be Monday, Tuesday, Wednesday, Thursday. Okay? And then you want to, for map date, you want to put 9-12. I might go this way with this. All right? And the map date changes when you hit zeros. Okay, so remember that. But local date does not. Okay, so this is still 9-12. And then here is going to be 9-13. So remember, map date is Greenwich Mean Time, or UTC or Z for Zulu time. That's the time it would be in Greenwich, England. But right now they're 4 hours ahead of us. So they are going to hit Tuesday 4 hours before Philadelphia hits Tuesday. Right? So our local time, if it's 12 UTC, that would be noon in England. We are 4 hours behind, so this is 8 a.m. 1800 would be 6 p.m. in England. We're 4 hours behind, so that's 2 p.m. here. Now, 0000 is midnight in England, so technically Tuesday begins. But if it's just starting Tuesday there and we're 4 hours behind, it still means we're Monday night here. So that ends up being 8 p.m. Okay? And then you'll notice these are going every 6 hours. So this is 9:13, and it is 2 a.m. because if it's 06, that means 6 a.m. in England. That means it's 2 a.m. here. Okay? So these are going to keep repeating. So I'm just going to copy and paste. You'll have to type them in, or I guess you would copy and paste too if you're doing this online. So remember that map date only changes on the zeros. And the reason I put the map date on there is so that when you're looking at the maps, you understand which of these columns that you are working with. But all of the answers in this course are always going to be local day and local time. So in this case, it's what would you tell people in Philly, not people in Greenwich, England. So even though you see 9-16 over here, whoops, we really don't have any data for the 16th. This is 2 hours at the tail end. So we pretty much are doing Monday the 12th through Thursday the 15th. Okay, now I'm going to hit that save, save often in case something happens. Okay, so that's the header. You always want to do that first. Okay, now we're going to look at the data that I posted or that I hand to you in class. And you can see that's the data right here. So I'm going to click on this. Oh, I have to go into student mode here. I apologize. Student mode. We'll go back to, can I get rid of that? Let's go back to forecast city data. Okay, so I click on Philadelphia, and this you want to print. Okay, so you can right click and hit print, or you can do file, print, whatever you have in your thing there. Okay, so when you save that, you're going to see something that looks like this. Okay, so I'm going to put that up on the screen here. And then I'll hand you this in class if you're in the hybrid course. Okay, so this box right up here, this is called FOUS data. FOUS, Forecast Output United States. Everything else down here is MOS data. The NAM MOS, the GFS MOS, two different weather forecast models. Those are computers that predict potential forecast, right? And then down here is the GFS-X extended. This you'll see goes way into next Monday. So you can see that for Philadelphia, it looks like, at least after today, temperatures are going to be a little bit lower, right, than they have been before. Okay, for a week out. All right, so let's work with the MOS data. Okay, now I'm going to save a copy of this. Yeah, I got to save a copy of this because I need to print this. And hand it to my students without all the stuff I'm about to write on it. Okay, so this says output from NAM 06Z September 12th. Remember, 06Z is the same as 06 Greenwich Mean Time or 06 UTC. That means this model was run at 6 in the morning in London time or Greenwich time. That means for Philadelphia time, Eastern time, this was 2 a.m. data. We need on the sheet, the first thing we need is 8 a.m. data, or 12 Greenwich Mean Time. So what that means is we are going to always start at this row, because this is the 06 hour row. See how it goes 6, 12, 18, all the way down to 48. You will notice that matches up here, 6, 12, 18, 24, all the way to 48. So that means the FOUS is going to be able to give us those columns certain pieces of information. Anything beyond 48 hours, you'll see we're going to have to go to the maps. Okay? So we take a look at this and we say, okay, we know this output was 2 a.m., 06. So 6 hours later, this actually would be the 8 a.m. Monday data. If I go 6 hours into the future, this row is the 2 p.m. Monday data. So you should probably get in the habit of highlighting these columns like this until you're totally comfortable. 24 hours would be 2 a.m. Tuesday. Then we have 8 a.m. Tuesday. Whoops. Still a chopstick typer here. My wife laughs at me. Then we have 2 p.m. Tuesday. I even text on my phone with one finger. You guys are all flying around. It takes me forever to do a message. 8 p.m. Tuesday. And then finally 2 a.m. Wednesday. And that should make sense to you because, I'm going to hit save here. If this is the 48 hours beyond this, 48 hours beyond 2 a.m. Monday would be 2 a.m. Wednesday. So you know you did it right. Okay, okay, so when you look at the FOUS, okay, the first thing I look at is the HH column. The HH column is going to be thickness. Okay? And if you follow the tutorials, you know that if it ends in 72 here, the number I always put in front, unless it's super Arctic polar vortex cold is a 5. So the models drop that out because they know it's always 500 something. So in this case, it's 572. So I'm going to put a 572 here. Okay? Don't worry about units. Okay? The next thing is PS. That would be station pressure at sea level. And the two digits they're ending is 11. Okay? Now, if you followed the tutorials, you know that they've dropped a leading 10 or a leading 9. That means we have two choices. This could be 911 millibars of pressure or 1011 millibars of pressure. So you might say, well, how do I know which one's correct? You always pick the one that's closest to 1013, and you can go over which is considered normal sea level pressure. So in this case, 1011 would be the correct one because that's very close to normal pressure. 911 would be either a supermassive nor'easter or a hurricane. Okay, so it's far more likely it's 1011. Okay, so we're going to put 1011 in here. Okay. And then when we look at precip, precip is always going to be a 6-hour total, and it's going to be right after the forecast hour in the PTT column. So what that means is, if we look at these three digits here, 001. Well, the format of PTT, the precip, is always going to be the first digit, then a decimal point, and then two more, meaning it's always done in hundredths of an inch of precipitation. So that would be 0.01. So here I would put 0.01. And what that means is this is a 6-hour total ending at 8 a.m. So the models believed Philadelphia between 2 a.m. and 8 a.m. was going to have 100th of an inch of precipitation. Very, very light. And as I'm recording this, there definitely was some rain overnight here. We're not that far away from Philly, so probably verified. They probably got at least 0.01 inches. Okay, so I'm going to hit save. So on the FOOS, you're going to get thickness, pressure, precip, and if you go through the entire FOOS, you'll end up with all of these rows with data in them. Okay? Just to let you know, if precip ends up being 0 somewhere, instead of writing 0.00, I tend to just put a little dash in there because then the non-zero numbers really jump out. And you don't want zeros all over the place because then you might not see some of these other things like 0.01. That's your preference, okay, but that's what I do. All right, so that's how you do the FOOS, okay? So I'm going to let you get my stuff here. Here we are. I'm going to let you do the rest because it's your lab, okay? Now we come down to the MOS. We have the NAM MOS and we have the GFS MOS. The NAM and the GFS are two different weather forecast models, two different numerical weather models. So it's almost like going to Doctor 1 and Doctor 2, a second opinion. They're both going to give you a prognosis on what your health is like in the future. Sometimes they very much agree, other times they disagree. And so when you do weather forecasting, the idea is if you get information from a variety of models, you can start to form sort of a consensus forecast. The two American models are the NAM and the GFS, and given the time frame in this course, that's really all we have time to look at. But there are actually quite a few other models from around the world that you can get access to either free or with a subscription. So we're good with NAM and GFS in this class. So what you notice up here is this is a little bit different than the FOOS. So the FOOS goes every 6 hours into the future up to 48 hours. These are actual Greenwich Mean Times. Okay, so that would mean 06 Greenwich Mean Time the 12th, 09 Greenwich Mean Time the 12th, and then 12 Greenwich Mean Time. Well, it turns out that's the first one we have on our sheet, right here, C12, UTC. So when you get the NAM, you're not using these first two columns. You're going to start with the 12. And then you're going to notice you're going to use everything that's a multiple of 6. So 12, 18, 0, 6. 12, 18, 0, 6. 12, 18, 0. Now you notice these last three, I'm not skipping anything. For some weird reason, and no one's been able to tell me, toward the end, they start jumping every 6 hours instead of every 3 hours. So what I do on my sheet, and I've already printed it this morning, is I highlight the 12, 18, down to WSB wind speed. So I highlight here, I highlight here, here, and so forth. And then these last three are highlighted. Okay. Now down here, the GFS, look at this one. It starts at 12. So you're going to start with this row, and then in the very end, you're going to get an extra one, right? An extra one that you don't have with the NAM. So I'll show you what that's going to look like in the forecast. FYI, I have examples. All right, so we go back to 12 and we see, oh, TMP, temp is 72. So I just come down here and I do 72. Dew point, 70. That's a very humid dew point. So just so you know, relative humidity is kind of a misleading term. Relative humidity, and we'll talk more about this in clouds, fog, precip, it just means how close the air is to being saturated or full. So if you think of the atmosphere as a sponge, it's basically how close is this sponge being to completely full. And it's based on temperature. So at very, very cold air, the sponge is tiny. Well, if it's full, you technically have 100% relative humidity, but there's hardly any moisture in there. You would never say in January, oh my gosh, it's so humid. But in the summer, when the sponge is much bigger because it's hotter, it could be half full, but there's still a heck of a lot more water in there if you were to squeeze it. So 50% relative humidity in summer is far more humid. So the good news is the dew point is a direct measurement, essentially, of how much water is in that sponge. 70s are very muggy. 60s are considered humid. 50s and lower are considered drier. And you'll see Philadelphia is going to start getting some drier air as we work through the next few days. Okay. So the next one is cloud. Cloud is OV. There's different choices. You see it in the tutorials. You have overcast is completely cloudy. Then you have broken, which is kind of like mostly cloudy. Then you have scattered, which is sort of partly cloudy. Fair weather is a few clouds, and then CL is clear, which means no clouds whatsoever. Okay. And then we have wind direction. Now this is the one you got to be careful on. So we have a 28. Okay. You have to add a 0 to the end of that 28. So that means it's actually 280-degree wind direction. Okay. So if we go back to lab number 1, and this is also in the tutorial, the MOS is going to give wind directions in degrees around the circle, not using these letters here. You do not want to write 280 for wind direction, because you have to do it like a person in Philly would understand it. So they're looking for like northeast, south, something like that. So 280 degrees is between 270 and 315, so it would be west, northwest. So on my sheet, I'm going to write west, northwest. Okay? And then the wind speed, you just put the number here. It's 0.3, so I just write 3. Okay? Now, something else about the wind direction. You'll notice that if I'm always adding a 0 to MOS, the MOS is never going to give you 45. It's going to give you 40 or 50 because it can't do a 5 at the end. So my rule of thumb is if you're within 5 degrees of north, northeast, east, these black ones here, just go with that direction. So if you see a 40 or a 50, just call it northeast. Right? If you see a 130, right, or a 140, just call it southeast. Got it? All right. So now on the MOS data, you're going to end up having all those filled in from the MOS. Now, the GFS is exactly the same thing, just a different opinion, but you're going to get one more column here because you're not skipping any. Remember, in the NAM, you skip the first two. The GFS, you start right off with the 12. Okay? And I'm obviously going to let you do that because it's your lab. All right? And then we're going to see this X/N row. Both of these have an X/N row. Those are 12-hour maximums and minimums ending at that time. So now you got to be careful. This 82 looks like it's under September 13th, but it's 00 September 13th, which is midnight Tuesday in England. So this is an 82 is ending at 8 p.m. Monday. So what this means is the NAM thinks today's max temp is going to be 82. Okay? The GFS agrees, 82. So I'm just going to put both numbers here. All right, second opinion. The 71, occurs under the 12 Greenwich Mean Time, which is 8 a.m. So what that means is between 8 p.m. Monday night and 8 a.m. Tuesday morning, the lowest temperature is probably going to be 71. That makes sense because the sun's up by 8 a.m. now. It's usually up around 6:15. So this is considered the overnight or morning low. So we put 71 here, day one low. And then the GFS thinks it's 70, so it's close but not exact. So we're kind of feeling comfortable that these are going to be the numbers. That's kind of a warm low. That's because that dew point was so high. And you're going to do the same thing for max, min, max, min. And when you go through the MOS, you're going to realize, wait, I don't have numbers for day 3. So remember, you're going to have 2 numbers for each of these and the day 3 low. But for day 3 high, you're not going to be able to get that. Actually, you're not going to be able to get day 3 low either. Okay? So then you come down to the GFS extended, and these hours don't match up, so ignore these. Just look always under Thursday, and you're going to see 64 and 80. That's the low and the high. So 64 and 80. All right? You're also going to be able to fill in these 4 and these 4 by putting in these numbers, 67, 55, clear, and 8, and then 73, 49, clear, and 13. Now, the wind is just speed. It is not direction. You do not get directions from the GFS extended. All right, so after you do all of the MOS and the FOOS, your sheet should look something like this. So we're going to go back to the forecasting FYI. Okay. And you see here's an example for Williamsport. Okay, see how I've highlighted the multiples of 6? And when your sheet's totally done, everything you see here in yellow, okay, should be recorded on your chart by using the FOOS and MOS text data that I either hand to you in class or I upload. You will never ever have these 3 columns right here. They don't exist. Everything up here that's in white, all that data comes from the maps. Okay? And a completed sheet, see this? These are the only 3 that should ever be blank. All this other stuff comes from the maps. Okay, so let's go back. So you know what your sheet should look like before you upload it. All right, so let's go back here, and we're on our, then you say, okay, so how do we get 850 millibar data? How do we get, the FOOS, the thickness pressure precip beyond 48 hours? Because remember, this is going to be, that's going to be filled in. Okay, so what I'll do is I'm going to pick the 72-hour map, and I'm going to go right down the line here. You still have to go back and do 54, 60, and 66, and you have to do all the 850 millibar temperatures. You also have to do these guys after 72. The reason I'm going to start and just show you 72 is because that has all of the boxes for it. Because you don't need to use the maps for cloud, wind direction, and wind speed when you have all that, whoops, undo. When you have all that data already right here from the MOS. Okay, so we'll start with 72. Okay. So what you want to do is, I'm going to open up a new tab. You want to type in NCEP models. Okay, and you want to click on NCEP models here. There's also a link given in several places on the site. You might even want to maybe bookmark this, right, so that you can immediately go to it. Okay, so these are all the different models. Okay, the 2 that we're going to work with are NAM and GFS. So I'm going to click on NAM, and then we're going to pick North America as our map display because that's what we want. All right, Now, what you will see over here is what we call model cycles. Every 6 hours, 4 times a day, new data is entered into the computer models, and they run all of the models to try to do a 3 to 5 day forecast. Okay? Our data is always going to be using this model cycle. Right now I'm doing this at 7:45 in the morning. By about 10:30 in the morning, maybe 11 o'clock, this model cycle, 912, 12 UT, will start to chug out. This will no longer be the default. So if you're working on this lab a few hours after I post it, you're going to always have to make sure that the 06 UTC is the one that you highlight. So I always click on it once just to make sure that's the model I want to use. The 3 links you're always going to use on here is 1500 thick, 700 RHHT, and 850 temp HT. Now I know there's a lot of information coming at you, but remember, this is a video. You can stop it and keep going back until you get it. All of this stuff is in the tutorials. Technically, you should already know how to do this if you've gone through the tutorials. But I know that just because you go through a tutorial once doesn't mean you're an expert. Every week that you do this, it's going to get easier and easier because you're going to do the exact same things every single week. You're just going to be looking at a different city in the country. And the weather obviously changes week to week. Okay? So I'm going to click on 1500 thickness. And then you'll notice another table loads down here. These are all the maps for that different hours. So 0, 3, 6, that matches up here, 6, 12, 18, 24. I said I wanted 72. So that means I'm going to come down here and I'm going to click 72. Okay, so this is the 72-hour pressure and 1500 millibar thickness map, and it also has precip. Okay, you can also use the isobars for wind direction and wind speed. So this map is actually going to be able to give me those 3 boxes there, thickness, pressure, precip, and wind direction, wind speed. Turns out that clouds have their own map, 850 millibar has its own map, but all the other ones are from this one particular map. All right, so the next question you might be asking yourself is, well, where's Philadelphia? Okay, some of the cities I pick, you might actually know where they are. Others, if I pick, let's say, Omaha, Nebraska, it'd be like, where the heck is that? So what you want to do is open up a different tab and do state map Pennsylvania. Go to Google Images, find a map that has cities on it where you can read it. This looks like a decent one here. And there you go. Here's Philadelphia right here. Okay, so Philadelphia is in the southeast corner of Pennsylvania. Okay, so now I know where I'm going to look on the maps. So I can zoom in a little bit by clicking on this. So I know that Philadelphia is right there. Now, sometimes students have a difficulty looking, seeing the United States. The National Weather Service has all of the state borders in brown. Personally, I think they should have used black to make it easier to see. All right, so I always say, well, here's Florida. Start with Florida. Everybody can kind of see that. And then we go up the East Coast. Here's New Jersey. This thing is Long Island right here. Cape Cod, Massachusetts. Here's Maine. Come down Vermont, upstate New York, Great Lakes, Pennsylvania, Ohio, Michigan, because it looks like a mitten, Michigan they sometimes call it, the Great Lakes again, Wisconsin, Minnesota, North Dakota, Montana, Washington. We come down Oregon, California, Arizona, New Mexico, the great state of Texas, Louisiana, Mississippi, Alabama, Georgia. You get it. So this is Pennsylvania right here. So Philadelphia is like right there. All right. So we'll start with thickness. As you've learned in the tutorials, thickness, they go by intervals of 6. The blue ones are 540 and lower, or you can say colder. The red ones are 546 and higher, or warmer. So I can see right here is the blue one, 540. I always try to find the first blue one because I know it's always 540 even if it's not labeled. Now, because I'm going every 6, this dashed line is 546, this dashed line is 552, this dashed line is 558, this dashed line is 564. So we see the 564 is just north of Philadelphia. Way down here is 570. Okay, so Philadelphia is right there. I'm probably maybe like 565. I'm warmer than 564, but I'm pretty far away from 570. So on my sheet up here for 72 hours, I'm going to go 564. 565, I said. Yep. That's how you do thickness. And then every time you look at a map, you do it the exact same way. Pressure is going to be the black lines. These are isobars. They are multiples of 4. So 4, 8, 12. So that means this is 16. Right? And you can see 20 out here. Here's a 20. Okay? So Philadelphia is so close to the 16, I'm just going to call it 1016. So that one was a little bit easier. So I'm going to go 1016. And then precip, this is pretty straightforward. The key, the legend is over here. And Philadelphia has no green shading. So that means 0 precip for Philadelphia in this particular day. And you can see most of the country is pretty clear. There's a little bit of weather out here in the mountains, but so we're going to put for precip just a dash, meaning none. Okay. Now you also can use these isobars to determine wind direction and wind speed. So high pressure, the wind is clockwise. Low pressure, it's counterclockwise. So I want you to pretend the isobars are like a train track and the wind is the train that rides along it. There's only 2 ways you can go on that track, right? So the closest isobar is this one. That means either the train's going this way or it's from this way. Wind direction is always reported where it's coming from. If you go clockwise around this high or counterclockwise around this low, you can see that the wind has to be following the isobar this way. And right when it hits Philly, looks like it's coming out of the north, maybe the northwest. See, it's coming down like this, and then it just kind of turns the corner. So it looks like Philadelphia has either a north or a northwest wind. So on my sheet, I might do something like this, north-northwest. Okay, as long as you're close, you're going to get credit for it. And the spacing of the isobars determines the speed. Like up here in Canada, this would be very windy because there's a bunch of isobars in a small space. Down here in the southeast, there's a huge gap between isobars. These would be very light winds. So Philly's probably sort of in the medium kind of wind speed. You can't really pick a number here. I usually just write light, medium, or windy. So in this case, I'll do medium. And then I hit save. Okay, so you would do the same thing for 54, 60, and 66, but you don't need to do the wind. And then 78 onward, you do everything that I just did, including the wind. Okay? So that's how you get those. Now, the 850 millibar and the cloud, those are separate maps. So what I'm going to do is I'm going to click back. I'm going to click the 850 temp HT. This is the one you have to do the most of them, right? So I'm going to click 72, and I think it's probably the most challenging map to read because there's just a lot of stuff going on. So I'm going to zoom in a little bit. Now, these are going to be temperatures in degrees Celsius at about 5,000 feet above the surface. So the 850 millibar temperatures often will show a very quick look at where's the cold atmosphere, where's the warm atmosphere. Okay? They're multiples of 3. And they also have these little flag things, which are wind directions, but those are not wind directions at the surface. You have to use the isobars like we just did before. These are winds 5,000 feet up, and those are not the ones you have to use. So in this particular map, you always want to use purple, blue, and red. So what I always try to do is I always try to locate purple, because that's always 0, even if I can't see a label. Every blue line to the north of the purple is a negative, so that's -3, for example. Every red line to the south is a positive, so that's +3. So if I start at 0 and I do 3, 6, 9, 12. Philadelphia is very close to 12. In fact, it's so close to 12, I'll probably just call it 12. But if you called it 11 because it's a little less, that's perfectly fine also. So Philadelphia's 850 millibar, I'm going to call that 12. And again, you would do the exact same thing for all of these different hours all the way across. You'd have to go all the way back to 6. Okay. Now we're going to go to cloud cover. We go back. Cloud cover is 700 relative humidity. So we click on that. Go to 72 hours. And this one's pretty straightforward. If your city is underneath any green shading, you put in overcast. If it's not under the green shading, then it's something less than an overcast. So if I'm close to the green shading, but not quite in it, I might go broken for mostly cloudy. Here, I might just say scattered or fair weather because it's kind of far away from these things. But there's some of these green lines, which means there's maybe some clouds around. So I might go here, I don't know, maybe I'll go fair weather or scattered, something like that. Okay, that's how you do cloud cover. So that procedure that I just did here, you're going to do for all of these guys over here, right? The 850 millibar, you're going to do this entire row, and then you're going to go back and do these, but you don't need to do the wind. Okay. Now there's two more things I want to show you here. 90 and 96. You will notice when you go back, and let's say I click on 1,500 thick, it stops at 84. There is no 90 or 96. So what that means is for the NAM, you can't get those two columns. But you don't want to leave them blank because that's a significant chunk of Thursday. So then what you do is, right, you go back and instead of choosing the NAM, you pick the GFS. Okay, then you pick North America. Make sure you have the 06 model time. And let's click on 1,500 thickness. Aha, look, there's a 90 and there's a 96. So the GFS goes deeper into the future. So what that means is when you want to get this set of data here, you have to go to the GFS 90 and the GFS 96 for the exact same things that we did over here. So the procedure is exactly the same. You're just using a different model to sort of finish the tail end of your week. Okay? And when you've done all that, everything should be filled in except for these two and this one. All right, so I'm going to hit save because I'm going to work on this in class later today. Okay, so the last thing I want to show you is how to save the maps. Because if you don't save the maps, as soon as tomorrow 2 a.m. arrives, these maps are going to be overwritten by the Tuesday maps instead of the Monday maps. So you probably want to get in the habit of saving all the maps. That will give you the entire week to work on them, which means you don't have to do the entire lab on Monday. The Foose and Moss are always available in Brightspace, and if you save the maps, it means every piece of data that you need to complete the note sheet, you're always going to have throughout the entire week. It also helps because I will save the maps today, but I won't from now on. If you have questions and you need help, and we do a Zoom or you come to my office, if you have the maps saved on your thumb drive or your computer, we can look at them together. Okay? So there's a lot of reasons why you want to save the maps. So here's how you save the maps. Well, first of all, you'll see in the lab tutorials, forecasting FYI, okay, how to save the maps for later use. So what I'm about to show you, all right, is already here. Okay? And these are the ones you have to save. So you'll notice that the 850 maps, you have to save a whole bunch of them. 700 relative humidity, only a couple, and sort of a medium amount here. Okay? Because these are all the maps that we use. So, for example, suppose I wanted to save 1,500 thickness maps, and I wanted to save the 90-hour GFS. Click on it. The best way to do this is to right-click on the actual link up here where it says image URL. Right-click on that, do Save Link As, and then put it in a folder. See, I've already done this morning. You want to stick it in this folder. Okay, I'll hit save. Okay, now you might get this security message like I have right here. Just say keep. Some browsers, if you download anything from the internet onto your computer, they immediately are suspicious. All these maps are fine. Don't worry about it. Okay. The issue is because they don't have HTTPS up here. They think the browser doesn't like it. So now I have that map. So you want to do that for all of these maps and times. And then you have all the maps. Now I believe that is it. Okay, enjoy the video. I hope you do well in this first lesson.